Hello everyone, I'm Mrinmoy from Samsung Research Bangalore and welcome to the presentation for a paper titled SHARDS, Efficient Shadow Removal Using Dual Stage Network for High Resolution Images. Existing deep learning based shadow removal methods are mostly limited to low resolution images and cannot scale to high resolution images. Additionally, many of these methods rely on heavy networks, limiting their real world applicability. The lack of high resolution datasets for shadow removal adds to these limitations. For existing methods, shadow removal quality progressively degrades as the image resolution is increased. Shadow removal as a task requires long-range contextual cues from shadow-free regions for effective shadow removal. As CNN-based networks have a fixed receptive field, at high resolution such context aggregation is affected. As shown in this performance versus efficiency diagram, existing shadow removal methods comes with a high computational cost which limits their real-world applicability. We propose SHARDS, a dual-stage approach for shadow removal for high-resolution images. Our proposed lightweight network achieves state-of-the-art performance on the standard ISTD dataset and the newly created SFHQ dataset while having the least computational cost. We also propose an efficient shadow detection network in this work. Together, we demonstrate an end-to-end system that can perform shadow removal on modern smartphone devices for high-resolution 4K images. We decompose shadow removal for high-resolution images into two stages using two networks, LSRNet and DRNet. LSRNet performs shadow removal at low resolution like existing methods. This is followed by DRNet, which restores back the details from the low-resolution shadow-free output using the original input image as guidance. LSRNet follows the encoder bottleneck decoder architecture. To handle dark shadows better, gamma-corrected images are provided as additional input to the network. To model long-range non-local dependencies and global context from shadow-free regions, self-attention layers are used. DRNet follows a similar architecture to LSRNet with minor changes. Due to lack of high-resolution datasets for shadow removal, we create ISTD-HQ, a high-resolution version of the standard ISTD dataset using a super-resolution method. Additionally, we create SFHQ, a new large-scale high-resolution paired shadow removal dataset. The networks are trained in an adversarial setting using the GAN framework. In addition to adversarial losses, a multi-level perceptual loss is also used. The proposed method outperforms existing methods on the ISTD and SFHQ datasets by 9.5 and 13.4% respectively in terms of RMSE metrics. Qualitatively as well, the proposed method produces outputs with the least shadow remnants and artifacts across different datasets. By decomposing the shadow removal problem into two stages, the outputs remain consistent even for high-resolution images, unlike existing methods, and this is achieved with the least computational cost. We also propose an efficient shadow detector network in this work. The network follows the encoder-decoder architecture with MobileNet v2 as a backbone. This is followed by ASPP for multi-scale context aggregation. Finally, low-level and mid-level features from the backbone is fused in the decoder for prediction of finer details in the shadows. Quantitatively, the network outperforms a similarly lightweight FSDNet across all the datasets. Here are some qualitative results on the SBU shadow detection dataset. The proposed shadow detection network thus complements the lightweight shadow removal network and together forms a practical and efficient end-to-end shadow removal system. Thank you. Please refer to our full paper for more details.